When loading from my Mannlicher 1905 pistol, the powder charge is very small, just over 2 grains. If I want to continue loading 7.65 Mannlicher, and maybe expand to other early semi-auto pistol cartridges, I need a way to easily measure out small powder charges. My main powder measure is an older RCBS Uniflow II, but looking inside, the diameter of the cavity for the powder is very large. It does work very well for rifle cartridges, with powder measurements of around 40 grains, but not at all for smaller amounts like this. To load 7.65 Mannlicher, I had been using my old starter measure, a Lee Perfect measure. The cylinder inside is a bit smaller, so it works better for these small charges, which is what it's set for now. My problem with this is that when I use it, it leaks everywhere. I'm not sure if the leaking powder is a reliable amount, or if it's throwing off the charges. There has to be a better way. And that's back to the RCBS Uniflow II. The cylinder is designed to measure between 10 and 100 grains. They make an optional smaller cylinder to replace this. That is designed to measure between 0 and 50 grains. Still a large range. Just one problem with that, it's discontinued. That's because the new Uniflow III has a universal cylinder. But to me, the cavity still looks pretty large. I'm not sure how reliable it would be to measure very small charges. They say it can measure from 0.5 to 95 grains, but again, I'm not sure. Back to the optional small cylinder for the older measures. The cavity is smaller, but I only need a measure for pistol charges, say 10 grains max. I don't need it to go all the way up to 50. Ideally, I'd have a cylinder with an even smaller cavity, the size of the screw, or even smaller. That's what I'm going to make. I actually have 2 of these RCBS Uniflow II powder measures. This way I can still use one for rifle and one for pistol charges. Because I want to go from my large cavity in the powder measure to a smaller one, that means I need to remake all of these parts, including the adjuster screw. This piece I'll call the bushing, and the main cylinder. The only parts I can reuse are the handle and the screws. Everything else will be made from scrap that I have lying around. But before I get started, just how big do I want to make the cavity in the cylinder? This measures 0.680. If the adjuster screw for the discontinued small cylinder is the same 3/8 of an inch as it is here, then the cavity there is probably around a 1/2 inch. That's not too much smaller when comparing diameters, but when comparing areas, it's roughly half, 0.363 square inches versus 0.196. That explains why the large cylinder goes up to 100 grains, while the small goes up to 50 grains. Or to be precise, it's 46% smaller. But still, both much too large to reliably measure the 2 grains that I have here. How would it measure if I cut the diameter in half to a 1/4 inch? It would be 0.049 square inches. That's 86% smaller than the large cylinder, and 75% smaller than the small cylinder. That sounds good in theory, but let's do a test to see how it would look. Here I have a straw, which is right around a 1/4 inch in diameter. I'll stand it up, hold it against the plywood underneath, and dump the powder in. I don't have a free hand to measure, but the height of the powder looks to be right around the diameter of the straw, a 1/4 inch. With some more math, I can calculate the volume, 0.012 cubic inches. Changing that formula around to solve for height, I can plug in the size of the large cylinder while keeping the volume constant. So if I had a straw the same size as the large cylinder, the same 2 grains of powder would be 4/100 of an inch tall. In other words, not a measurable amount. I'll make the cavity a 1/4 inch in diameter. I'll start with the cylinder, making it out of this piece of scrap steel. I'll get the outside shaped first in the lathe. On the mill, I have the cylinder stood up in order to drill out the cavity where the powder will go. I'll first find the center. That's the cylinder completed, the main part at least. Next I'm going to make the adjuster screw. As you can see, the original has a very fine thread on it for precise adjustment, 32 threads per inch to be exact. That's an odd size, and I don't have a tap or a die for that. The closest I have that's larger than the 1/4 inch of the cavity is a 5/16 24. Not as fine of a thread, but the greatly reduced diameter of the cavity should make up for the slight loss in thread pitch. I'll get the adjuster turned on the lathe from this piece of steel. Because the cavity in the cylinder is small, I made the adjuster backwards from the original. That has the larger end going into the cavity, then a small adjustment knob on the opposite end. I made this one so that the end going into the cavity is smaller, allowing the knurl knob to be larger, which in a way will make up for the coarser thread. Next I need to make the bushing that connects these two. I already have the cylinder cut for it to thread into. The bushing also serves as a stop for the cylinder to prevent it from over-rotating in the body of the powder measure or slipping out the side. I'll use the biggest piece of scrap to make the smallest part. Here's the bushing. Off camera, I also made a new locking nut for the adjuster. And that's all the parts completed. I'll get this assembled. Due to how the adjuster was made, everything could be installed through the front, unlike before when I had to remove the adjuster screw through the powder reservoir. Then I'll mount it on the stand. Looking from above, you can see the cavity expanding as the adjuster is unscrewed. I'll set it to the smallest it can be, while the cylinder can still be rotated, and lock it down. Then I'll add the powder. I want to be able to quickly measure the charges, so I'll set up a digital scale. If I was actually loading cartridges, I'd double check on my beam scale, but this will do for testing. With the pan added, I'll zero out the scale. Then I can weigh the smallest amount of powder it will drop. These scales aren't particularly accurate, especially with very small amounts like here. Of course it's showing 0. I'll dump the powder and redo. No surprises, 0 again. After all, I counted only 15 small flakes of powder. I'll dump this and see how much it will read after unscrewing the adjuster a quarter turn. Zero again. This shows how these scales aren't the best for tenths of a grain. Oh, I didn't touch it, but it did move for a second. It's still not much at all, but there are noticeably more flakes than before. Again, I'll dump the powder, and then see what another quarter turn will get me. .3 grains, but with noticeably more flakes than previously. Maybe all I'm proving here is how insensitive these scales are. This time I'll weigh the maximum powder this will drop. I designed the adjuster to have around 1 inch of travel, but since it will come out the front, I need to be careful how far I unscrew it. Right around here is the maximum. That's 5.2 grains. For reference, with this same powder, my load for 9mm Largo is a half grain less than this, so this cylinder would still be good for more powerful cartridges as well. Of course, if I want to call this testing even remotely scientific, I'll test it again. Same 5.2 grains. I'll reiterate that if I was actually loading these charges, I'd double check on my beam scale for accuracy. I'm pleased with the results of the cylinder here. Am I being paranoid about the reliability of a larger cylinder for small charges? Maybe. Are there other powder measures that work better for smaller charges? Maybe again. But for someone like me, I just like to make things, and it's even better when they fulfill my needs while using parts and scrap that I already have laying around. Of course, this still needs repeatability testing, which I'll do off camera before using this to load cartridges. Thanks for watching.